Hi everyone, I am Manthan Chabra, a security researcher at Altered Security, and I'll be your instructor for Module 4 Initial Access Techniques. In this module, we'll be diving into the security implications of ClickOne's deployments and how attackers exploit them by backdooring legitimate applications. We'll cover the fundamentals of ClickOne's deployments, demonstrate how to modify a trusted application to execute malicious code, and explore its advantages as an attack vector. Let's dive into the concept of ClickOnce and how it can be used as an initial access technique. ClickOnce is a Microsoft .NET Framework technology designed for seamless deployment of Windows applications with minimal user interaction. However, this convenience also makes it an attractive target for attackers. By modifying a legitimate ClickOnce application to execute malicious code, adversaries can bypass security controls without requiring administrative privileges. Since ClickOne's applications are often trusted and whitelisted in enterprise environments, they provide an effective method for stealthy compromise. Additionally, ClickOne supports URL-based deployment, making it an ideal vector for phishing campaigns. We can use the provided Google and Bing docs to identify publicly hosted ClickOne's applications. For lab demonstration, we have already installed a ClickOne's application on the Windows VM. Let's take a look at the installed application TPMS Desktop. After we open the TPMS Desktop application, we are greeted with a Accept License page. After accepting the license, we have a login page in front of us. Let's take a look at the application installation folder. To access it, first we'll go to the local app data directory. Then we'll go into the apps folder, the 2.0 folder, and then we'll go 2 layers down into the folders with random string names. The first layer and then the second layer. We'll see a list of multiple installed applications in this folder. We are interested with the folders with the name starting from TPMS. Let's investigate the first folder. The first folder has the executable updated.exe. This means that this component of the application is probably responsible for application updates. Let's take a look at the other folder. This folder seems to contain files related to the application. We can also find the primary tpms-desktop executable. Running this executable will run the application. ClickOne's deployments rely on manifest files. There are two important manifest files that we need to focus on. The first one is the application manifest with the extension .exe.manifest. This manifest file defines the application metadata such as required files, dependencies, and permissions. The other manifest file is the deployment manifest with the extension .application. This manifest file is responsible for deploying and updating the ClickOne's application. The application manifest can be found in the application installation folder. For this lab demonstration, we have downloaded the deployment manifest in the evasion/tools directory. Now that we are familiar with the ClickOne's manifest files and our ClickOne's application TPMS desktop, we'll start backdooring it to host our malicious payload. We start by opening the application executable in DNSPy and looking for non-strongly versioned DLL references. Let's take a look at it in our Windows virtual machine. We'll open DNSPy from the evasion tools directory. And open the executable in it. After DNSPy finishes decompiling the executable, we can take a look at its references. To find a suitable DLL to backdoor, we need to find non-strongly versioned DLL references. We can find them by looking at the public key token equal to null attribute. Looking at the DLL references here, we can see that there are multiple suitable candidates for the backdoor. We'll try to find a method that exists in one of these DLLs and will be executed on running the application. Looking through the classes, we find a call to the getLogin image of the tpmspad.vlogin class. Clicking on the method takes us to its declaration. This method looks to be a part of the common functions.dll. Looking back at the references tab again, we can see that this DLL is not strongly referenced. The getLoginImage method is also executed when a login page pops up. This means that this backdoor method will execute as soon as the license is accepted. Now that we have a suitable method to backdoor, let's edit the method and add the namespaces and the code to download and run an executable. We'll go to the getLoginImage method in the Assembly Explorer and edit the method. We'll add the required namespaces and the code to download and run our executable. We'll be hosting a message box executable on our web server on port 8000. The code will download the executable, store it on the file system with the name mbox.exe and run it as a process. Next, we'll compile the DLL. After compiling, we'll go to the File button and then save the module. To test our DLL, we'll host our executable mbox.exe on a web server using Python. Now, if we go to the tpms folder and run the executable, we'll see that our executable is fetched and the message box is executed. Now that we have successfully backdoored our application, we'll start working on deploying it. First, we'll create the application folder structure. To deploy our ClickOnce application, we'll start by creating a folder with our name of choice. Then we'll copy the deployment manifest to this folder. After copying the deployment manifest, we'll create a new folder called application files. After creating the application files folder, we'll open the deployment manifest and copy the directory name inside the application files. We'll need to strictly create a folder with this specific name inside application files. Next, We'll copy the contents of the application installation folder inside this directory. Now that we have our deployment structure in place, we can start modifying the manifest files. We'll start with the application manifest. We'll open the application manifest in Notepad. In the application manifest, we'll start by replacing the public key token with 16 zeros. Next, we'll look for the common functions.dll. We'll check the size of the updated common functions.dll and update it in the manifest file. We'll also calculate the digest for the updated DLL using OpenSSL and update it in the manifest file. We'll replace the updated digest in the manifest file. Next, we'll move on to updating the deployment manifest. In this manifest file, we'll update the public key token for both deployment and application manifests and replace it with 16 zeros. We'll also update the deployment provider link with our URL for the hosted application. We'll update the size for the updated application manifest and we'll also update its digest. We'll open the deployment manifest in Notepad. We'll start by updating the public key tokens with 16 zeros for both the deployment manifest and the application manifest. Next, we'll update the URL in the deployment provider tab. We'll update our IP address and the port. We'll use the port 8080 to host our ClickOnce application since we are using the port 8000 to host our messagebox executable. Next, we'll calculate the digest for the updated application manifest using OpenSSL and update it in the deployment manifest. We'll save the updated deployment manifest. Our ClickOnce application is almost ready for deployment. As a final step, we just need to add the extension .deploy to every files except .manifest and .cdf-ms. We can use the provided PowerShell one-liner to do it. We'll use the provided PowerShell one-liner to add the extension .deploy. Looking at the folder, we can see that the .deploy extension has been added to the files except for .manifest and .cdf-ms. Our application is now ready for deployment. To deploy our ClickOnce application, we'll open two instances of WSL. We'll use the first WSL instance to host our MessageBox executable. We'll use the other WSL instance to host our ClickOnce application. Let's open the URL in our browser. We get a prompt to open the application and install it. The application finishes installing and opens. After the application opens, we are greeted with a license agreement page. After accepting the license, our message box payload is fetched and executed.